Hello and welcome back to Compiler Programming. Today I think I want to try to set up exception handling in the language. So not particularly for the purposes of usage inside the language, but we still need to integrate with the main system of Windows to do that stuff. And right now, basically, if exception happens, there is, I think, some default handler or that is inside of operating system itself, and it's just not very useful. What happens is we just if we don't have a debugger, we just crash, and there is absolutely no information about what actually happened. Would be very nice if we at some point would be able to print a stack trace, but that is a bit too much to do in one go. So I want to start on that and just attach to every function an exception handler that would simply call out to some C procedure that we will define here, right? So let's define something like, well, first of all, we need to have the type definition for how exception handler looks like. And it's a bit of a beast to look at. So yes, I think that is the type definition that we need to have. So how do we do that? Well, have exception disposition, and then I don't know, program test exception handler, and then what? Well, then we need to pass these parameters to it, clean out all the Windows garbage from the list of parameters. I don't care about in out. Okay, so that's our handler, and I think we also need to figure out what is this exception disposition. So let's Google for that. So there is this stuff. What does this say? Okay. Well, let's try to return one of these and see if that works. Well, we probably want continue search, so we don't actually want to handle the exception, so we want whatever the default mechanism is going to be happening. And I also want to do printf, I don't know, exception happened. And we're not gonna go into like exception types and whatever. I just want to see these things show in my console. And I'm not even sure that we will be able to see the debugger, so we might have to launch executables separately for this to happen. But let's see. I also found another article that seems to be very helpful. It does all of the stuff that we are doing as well with the definition of the unwind info, and also has an exception handler example somewhere over here. Yeah. So the inside of the structure, let me sort of find this. I think it's inside the value.h. So we have this unwind info. Yeah, so right now we have this set up very strictly, that we have two unwind codes that are necessary to encode any size of the stack allocation, and then there was this optional expression data and optional exception handler and function entry. So now I want to bring this exception handler into the mix. So do it like this. And I think this should not cause any issues for us because it's just an extra 4 bytes at the end of the struct. So we are taking up more memory when we are writing out both the executable and cheat code. But apart from that, tests should still pass fine, and they indeed do, so that's good. Okay, so we have this exception handler, and if you go back to this bright white article, then we'll see that what it puts into the exception handler is not the address of the function, but instead a trampoline to that function. And I wasn't exactly sure why that was done, but then I realized that because this is JIT code, there is actually no guarantee that the address that we will get is like that. Basically, that the difference will be 32 bits, and we can call the right address. So the safest option here is to put the full address into here, and this 32-bit offset is an offset into our section that we created ourselves. And this seems like just a good approach. So I want to replicate that as well and see how it goes. So let's do that trampoline. Unlike that article, we can actually do it with a bit nicer setup, I'd say. So we can do, how can we do this? Should I just add a function builder? Maybe, function count, global data size. So I'm trying to figure out what would be the easiest way to make sure that these estimates are also all correct. Well, let's just create a function builder and add it to functions and let it handle all the stuff sort of as it should, maybe. Okay, so let's just start. We need to have, so function. Actually, no, I don't want a function builder because this code is quite raw. Instead, I probably want to have a simple array of instructions. So array instruction trampoline is what? Dynamic array make array instruction, and I don't particularly care what is the size of it, it's fine. So we can do push instruction trampoline and instruction. So first we need to move the address of our exception handler into arrayx. So let's do that. Let's do move rex, and we need immediate 64 of, we need to probably cast this here to u64, and this is our, actually to s64 probably, and like this. So this would be moving the address of this exception handler into arrayx, and then we just need to call arrayx, and this would be our trampoline. And call arrayx. Does this compile? No, it does not. Probably because this file does not actually import. So order is wrong for the compilation. You know what? Let's just move it out into the function where we have all the code stuff. So maybe we can go function. Actually, function in code was a nice place to put this. And we'll put it here, and we will say How do we call this? Make trampoline or something, and it should return to us the address of the function. How do we handle it in function and code actually? This is unwind info, program code base array, function start. So we are just updating the prologue label, and I guess that is what is used for jumps. Okay. Well, let's I guess we can let's consider this. What do we need to return from this? We need to understand where our trampoline is located, and maybe the best approach would be to just say, yeah, let's do it like function in code. So u32 function or function make trampoline. We might actually need to use trampoline for other stuff as well. And here I will just accept function type pack, I think it's called. Yeah, so that should accept any function, and it also should accept fixed buffer where we are actually gonna put this stuff. And then we might not even need this array. We can just do encode instruction directly like this. And the address that it's going to return is just the occupied of the buffer, right? So the position within this segment where we need to call this. So this is what we'll do. We'll need, say, u32 result is buffer memory occupied, and of course we need to turn this into 32 bits, but let's be safe. Okay, and this is what we're gonna return. Now we need to put this stuff into here. So this is our first instruction, and the second instruction is very easy. Actually, it looks like I should put another pair of braces here. And here it's easy, it's just call array x. Okay, that looks good to me, except this is now a function. Okay, and that's built. Memory, buffer. What don't you like about... because it's not memory, it's just activate. Okay, and encode instruction needs a builder. That is very unfortunate. Encode instruction. It is in the coding. Why do you need the builder? Tell me. So this is for the stack stuff, and relative. Yeah, I think I can just pass a 0 in there, and I will add a 2. Maybe we want a builder here. Too many braces. Okay, good. So we have a trampoline, or at least we should be able to add one. And let's just hard code this or put it here and say that max define max trampoline size is gonna be what's it? Let's look at that article. So it's gonna be bright. I guess we have 2 bytes, and then we have, or actually, this shouldn't be called. It should be jump, because we are just trampoline. So it's good that I looked here. Otherwise, it would be a bunch of time that we spend for nothing. So 2, and then we have 8, and then we have 2. So ideally, it should be 14 bytes. Let's just say 32. It doesn't really matter, I think, because we use it. Let's put like this, and we might want to tighten it later. I also can return sort of a pair, but doesn't matter. It's 32. So here we'll do it like this. So we just overestimate now how much space we actually need. Then what happens? We allocate the buffer. We put all the data buffer stuff into it. Then we reset all of this, and we allocate unwind information. Then we actually encode this stuff. Where does good memory come? Allocate array. Okay. So this actually can go here, so it is easier to understand that this is not part of it. Like, we don't care about code memory when we are doing this. And now that we have code memory, we can do our trampoline. So we can say U32 trampoline virtual address is make trampoline of result buffer, and we need to pass that program test exception handler stuff to this function. Where was I? Here. Okay. So do you build max estimated trampoline size? Yeah, that's supposed to go into the header. Yikes. Whatever, let's just put it in here for now. Or yeah, we do have to put it in header. So function.h, we'll just shove it in here, make trampoline, and since we are putting it here, we can also put the constant next to it, so that's good. Good. Okay, we have trampoline virtual address that is created, and we're gonna shove it into exception handler. Is this okay? Again, I think nothing should happen when we try to run it. I mean, like, we should, all the tests should pass, but apparently they do not, so that's a bit awkward. What is making it go nuts? Is it this line, or is it the fact that we are adding trampoline at all? So let's just do it like this and then see if that does anything. Okay, so it is the fact that we are adding some code to the top of the function that is making us unhappy. Okay, let's find out what is actually happening. Okay, let's run. Location was a null pointer. Okay, so we couldn't find the encoding, and this made us very, very unhappy. Okay. So what did I screw up in this thing? Let's check. Let's go to instruction.c and we will look at. So first, well, mov should succeed, right? This seems perfectly fine to me. Like this, we should support this stuff. I guess we can figure out which instruction is causing this by just doing binary search into instructions. Okay, so it is jump array x that is causing trouble. So let's find what jump says, and yeah, we don't have the encoding. Okay, cool, that is pretty easy to fix. So let's go. I actually found this website, which I think is a bit nicer to look at than the other one that I use. I will link it in the description. And we have that is not what I want. But this is x86. Yes, so I have to actually look at this one. Let's look at jump. Okay. So I guess this FF4. Yeah, I guess it is this one that we need. REAP is 64-bit offset from register or memory. Okay, well, let's try it out, I guess. So we have FF, then we have opcode 4, and then we have RM64. Cool. Let's try to run it again. Well, it did encode something. Let's actually look at what it looks like and compare it with the code that we have there. Or maybe we can compare it with this and say if my internet cooperates, which it doesn't want to. Okay, so it's fine. Now let's continue here. So encoding trampoline does not do anything. Now we will actually add the exception handler. Let's check that this still works. It does. Okay, the internet, are you alive? Apparently not really. Okay, and the next thing that we need to do, which is the scary step, is to go here and add a flag. And we need to say that we actually now have an exception handler in this unwinding procedure. So let's see what is gonna happen when we do that. Yeah, so this is unwind flag eHandler. You go into here. Actually, we can do it here to have it more contained into one place. So unwind info flags. Yeah, that makes sense. What is it called? It's, yeah, I always forget about uppercase or title case version of Microsoft stuff. Okay, now is the moment of truth. So ideally what should happen now is that when we have this test, let me open it up. So we have this test on exception. So what should happen is that we will get the exception in the function itself. We will then call the trampoline. Trampoline will jump into this handler, and we will print the exception. This is what should happen, but whether I understood everything correctly is a completely different matter. So I will want to see it with my own eyes. For that, I will go into here. I will look for the exception, and I will stop here. And yeah, Visual Studio, I will update you later. And I will try to run the tests. Okay, we at least got to this test, so not everything is completely borked. So let's see, we go in here, we call this stuff. We do this, and what is the actual instruction that is completely bogus there? It is dividing by 0. So this call should be fine. I step inside of this call. I get to here. Move, extend, and this is where we should get the exception. And I don't know what actually debugger will do when I step now onto the next instruction, but let's see. Okay, so we got to this exception handler. But this is exception handler in our tests. It is not the exception handler that we set up for the function. So that's awkward, I guess. Yeah, it just continues the tests. Okay. Did we print anything? Not really. Where is the exception? Is somewhere here. Yeah. So something does not seem to be happening like it should. And I'm not exactly certain what is, how to debug now all of that. Okay, so let's recheck. Let's open that article again, which I assume should work, but you never know. So what is happening here? Again, this is our, this is their exception code. This is a trampoline. Trampoline, I assume, should actually be fine in our case, although we can check. Then there is this stuff, unwind info. Okay, we are putting this stuff in here. Yeah, so this seems fine. They're just putting the address into the exception handler, and it does it go after the, let's verify here. Yeah, so we have unwind codes and then you have an exception handler. Okay. How else can we test? Is it possible that you can't actually print anything from here? Is it like debug break? Oh, okay. That is very, very strange. So we get this from array, we add the flag, we have the trampoline. But the thing just refuses to go there. That is kind of not nice. Oh, I know what's going on. Yeah, that's unfortunate. At least I think I know what's going on. Let's do this back. So I think, yeah, we need to change this up a bit. The problem is that this is this variable sized structure, and we are putting count of codes, right? And this can be 0, 1, or 2. And in that particular function, I think it's 1. So we put 0 into the second unwind code, and probably the runtime sees 0 in there, and it just, even though we said that we have an exception handler, it's like, okay, well, I guess he gave it 0, so we're not going to do anything. Or the zeros thing is actually it should be 0 anyway. So no, I'm not sure exactly what's going on, but let's fix it regardless, because this is actually, no, it's not 0. Yeah, okay. So let's do it like this. And then we have a problem in here, right? Where we are adding this, and instead of this stuff, we should be saying an unwind code or something, unwind code, and we need to put unwind for count of codes, I think it's called. Yeah, it's count of codes. We need to put it there, and oh, but it's 32 bits, so actually it needs to be yikes, this is gonna be a mess. So this needs to be 4 or 2 plus size of u32, no, yeah, no, 2 plus 2. Let's do it that way. And here we need to take this address, so u32 exception handler address is P32 star actually it needs to be star, and like this. Yeah, that seems right. So we are pointing just after whatever many codes we put in. And now we do this. And this should do something. Okay, let's try that again. So disassembly, call, divide, and damn it. We are again at the wrong place. So that kind of sucks. Well, let's try to look if this thing actually looks at all reasonable. Sorry, it's just printf. So, well, this looks okay. I mean, it is at the sum address. That seems fine to me. I think we are putting the exception handler at the right address now as well, but it's very unclear to me how to check that. What if we remove the try catch? So what is going to happen if I just do this? I mean, obviously test will fail, but the question is, will we end up in a better place? Doesn't look to be. Honestly, not exactly certain where to go from here. So let's just recheck everything again. And I guess my question is, do we ever get to the trampoline? How can we check that? Well, we can put some crap into trampoline itself, although I have no idea what it will do. So let's just put int 3 into here and see what's gonna happen. It does not look like it does anything. That is very, very frustrating. Okay, so unwind info. Let's look at this struct, I guess, and try to understand if it is doing the right thing. So let's go here and let's see what's going on. So we have this unwind info. We put the flag here. Oh, what is our address? Does it make sense? Well, yeah, it seems to be some offset into the struct. So it is like it's 4 bytes into the struct. Does it seem right? Where is the definition? So this is 1 byte, 2 bytes, So 3 bytes, 4 bytes, and if there is no unwind codes, then yeah, okay. So this seems fine. We put stuff in there, and if we look in here, we should get, okay, so it's little endian, it's 18, and if we look at our trampoline virtual address, it is indeed 18. So that, all of that seems fine. I wonder if trampoline is a jump, like if it's not an absolute address but a relative address. Let me read this section a bit more carefully. So that's not what I'm interested in. I want to know in exception handler, what is it? An image relative pointer, specific exception, or termination handler. So what if we try to put this flag instead? Will it be any better? Let's see. Nope. Just does not want to do anything at all. Okay. I guess let's undo this then and keep the original one and try to figure out what's going on. What else can it be? So this exception handler should only be executed after hours. So this one should totally happen first, but it doesn't. Okay, let's go back to that article. We're gonna be very bright again. And let's recheck that everything makes sense. So the article allocates some memory. It puts the problem, doesn't matter what the exception is. I mean, we have division by 0, it's sort of the same thing. It should be the same stuff. Then we have our trampoline, and right now our trampoline contains complete nonsense. So that's something. And this is just checks, creates unwind info, and he actually converts it to dword64, but I'm not sure that's correct. I think that this ulong, I believe, is 32 bits. We can verify that. Holds unsigned, but this is not what I want. Okay, whatever, let's just print it. would be faster probably to figure out what is the size of the thing. Print f %LU size of has size t. Whatever. What? Requires argument unsigned x64. Didn't they convert you? Okay, now I'm even more confused. But I can just probably hover here and get the answer that I'm looking for. If I can find it. So there is long 64 and there is just long. Unsigned long, what is your size? This is useless. I think that it is 4 bytes. Can I convert you to this and make you happier? Okay, whatever. Yeah, it is 4 bytes. So our code also seems to be just fine. I'm a bit puzzled, to be honest. I wonder if we need to do some special voodoo magic to force the system to have exceptions, but that doesn't look to be the case, to be honest. Oh, I'm super stupid. Yeah. Well, that would explain it. We were writing something into exception handler and then overwriting it in here. Okay, that was a wild goose chase. Well, let's see what's gonna happen now. Well, now apparently we crash, which is progress. Let's see what actually happens. Well, apparently we really crash. That Visual Studio Debugger is... yeah, we crashed Visual Studio Debugger. That's impressive. So something did not work out at all in this stuff. What if we comment out? The exception. Nope. Okay, what if I just put the exception handler but don't put the flag? So that should still work. Okay, that is good. So at least we are not overwriting some weird memory of the next unwind info or something like this. So this should be fine. It is this one that is happening, right? What if I change the type of the handler? Okay, you are very, very unhappy. But which test is it actually exploding on? Yeah, so this when exception actually happens, that is where things go sideways. Yeah, the rest of the stuff is fine. So it is this stuff that is going bad. So let's try again to step and see what's going on. Maybe it will fare better this time, but there is absolutely no guarantee. Okay, first of all, this should be E. And also here, let's rebuild. And let's try again. Okay, we go to assembly. We try to go here. We call. We call. We try to do the division. And now we should actually jump to that handler, to the trampoline, I think. Access violating, writing to the location. What? So we are at some very weird address. Actually, no, that's not too weird. So we have this. So checker, which is our function, it is at 45 and we are at 20. Given that trampoline is the first thing inside of the code, it seems plausible that it's at address 20, but I'm not sure I'm able to test that in a better way right now because we are not putting the buffer back into the program, I think. Buffer functions. Yeah. So it tried to write to this location, which is, I don't know. Okay, let's do something different. In that example, I think he was just going over the instruction that caused the problem. And if I can make that happen, that also will be totally fine to me. Yeah, but he's also doing printf. So I'm not exactly sure. It is also possible that this is completely bogus. Like, did our internet actually survive? Yes. So jump rex. Jump rex is ff20 and he's doing ffE0. What is ffE0? Jump rex. Okay. Yeah, so I was just putting the wrong thing. Yeah, we don't want to jump from the thing this. Yeah, okay. So that's fine, but let's check what we encoded. So let's just go step by step very slowly. That would be going to function, I think in here, trampoline, and go inside of here, and let's run. And I want to look at the buffer. And I want to look at the memory. I think it should be possible to... Okay, let's add this to the watch. Buffer memory. Buffer occupied. We have a bunch of zeros at the beginning, which is kind of interesting. But this is reserved stuff for unwind codes, I guess. So the result then is 18. Okay, that's fine. Let's encode this move and look at it. So this is 48B8 and then the address of the function. Well, that seems legit generally. Let's check the address, I guess. And okay, so an F60 6D 4D 6B. That does not actually look correct. Or am I crazy? And I can do U64 or actually unsigned long star of buffer memory 0x18. Am I doing this right? Okay. It's easier for me to figure out that way, so yeah, that's better. And now we will go back to here. Actually, yeah, this is not right, I think. But yeah, it's a wrong address. This should be plus 20. No, it would be 1A. Huh. This is funky. So we have address of the function that we are trying to put in there, and the first part seems to be correct, but then we just have complete crap afterwards. I'm very confused about why that happens. So this is correct amount of bytes, but why? So it's already here that it's not correct. So here I have one address, and then when I get to inside, for some weird reason, I get different address. I do not understand how that happens. Okay. let's change things around. Let's just pass U64 here. Actually, I have to pass it as S64. So address, int64 of address, and in here I will be very explicit where I'll say trampoline address is like this, and I'll just convert it to S64. Okay, I need to update the type here. 64 address. What's going on? Missing stuff here. Okay, let's look here. What is going on? How is that possible? We have a function and I want to convert it to a number and I get completely different number from what it's supposed to be. What the hell? What if I cast it to U64? Is that better? Maybe I'm just doing something weird and I'm not supposed to cast it to a signed address? Nope. It's still way off. There is something I'm really missing here. Can I like edit this variable? Quick actions, set next statement, quick watch. Copy. I'm probably missing something very, very obvious, but I'm really missing it at this point in time. So now you have the right address. So it's not like it cannot hold this. You know what I'm gonna do to make sure I'm not going completely insane is I'm going to do this conversion, right? So I have this address now. Now I will do the opposite. I will say that it's gonna be function type opaque test is function type opaque of yeah, trampoline address, and then I will want to try to call this, and let's disable all of this stuff, and this should succeed because yeah, like it doesn't matter that the prototype of the function is incorrect. Actually, I can even give it correct prototype. I will have to pass a bunch of stuff in there, but it's fine. let's do it right. Let's give it the right prototype, which is defined somewhere here. Yeah, you're here. It's called P exception routine. Okay, so, and I guess I need to say 0, 0, 0, 0, 0 would be totally fine set of arguments since we are not doing them anyway. Okay, let's see if that crashes, because if that crashes then everything else is wrong, but that does not actually crash. What is going on here? So yeah, we can call that function. That is perfectly fine. I wonder if it needs to have particular so it needs to be static to be in the same, I don't know. Let me check that. First I want to check the addresses here. Okay. Trampoline address is still different from the actual execution address, but this is still fine. Do I need to look to like, I thought I didn't need to do address of, but now I'm starting to doubt myself in all the categories. Yeah, that doesn't change anything like I thought. So these two are, I think it's just Visual Studio is doing something weird where it gives me one address here, but then it shows the right function inside. So I mean, yeah, we can go there, but this is actually a pointer. So we wait. Do we get a pointer to the function instead of the function itself? That would sort of explain it. Test. What if I say that you're actually no, I cannot. No, that doesn't make sense. Okay, I have no idea what's going on right now. This would be a very frustrating video to watch. Okay, so this is fine, I guess. but that also means that I'm kind of out of ideas at this particular point in time, because this should work, kind of. We stopped at the point where we were verifying that this encoding makes sense. So let's do that. Buffer occupied. We have some address in here, right? So 23. Well, it didn't code it correctly, at least. Yep. And then we have FFE0. So all of that seems completely fine to me. We have code memory starting here, so this is a totally legit executable piece of memory, and this is not what we were getting as an error anyway, so that's all seems fine. I don't know. I just do not know. Let's verify that we are still very much crashing. So yes, something inside of our stuff is just simply not correct. What is the address of checker? Okay, so this is a stack trace, right? We were at 4E. Which is already strange, because this is 4.5, but maybe it cannot really do proper stack trace in this case. Then we get to this 6C. So let me try to look at what is at that address. I want to cast you to void star. Actually, no, I want to cast you to this nice unsigned long, or maybe char 256. That is not very nice. Okay, you're just char pointer. No. And now I want to look at 256, whatever of you. And let's see. Whoop, no, go back. No, that's not what I want. R. Yes. Okay. Sort of back, I guess. I was in watch 1, and this is our code. So this is at 45, but I'm actually interested at 20, because this is where things go bananas, right? So this address, and we are trying to execute code here, and this is not the correct code at all. So we should be at address 38, but we ended up at address 20. So it seems to me that the exception handler address was just not correct. So we are putting it in the wrong place. Okay. That is at least a clue to what's going on. Let's recheck this. So we have count of codes. Let's go back to the documentation and verify that this makes sense. We have we don't have chain info. We have handler. Okay. Image relative pointer to either the function's language specific exception or termination handler. By image relative pointer, I assume they mean that it is, and they even say here that is ulong. We verify that ulong is the 4-byte version. We have unwind codes, which are 2-byte per thing, because that's U short. So if we had like this, data can be empty from my understanding, so this is also fine. And here, let's verify. Yeah, so this seems totally legit to me. Okay, let's check. So I guess I want to just break here now again. We should be inside of the hardware exception. Yeah, that's the first test. That's good. And we have our unwind info, and we can look at the codes. So it looks like we actually do have one code. I wonder if the handler always needs to be aligned to the right boundary. I don't know. So now we should have this 1 and 2 set to some, basically this should be 18 and this should be 0. That's very unfortunate that unwinding the info went out of scope and we cannot really look at it. Well, I guess I can do this stuff. I mean, this looks fine to me. The only thing I can consider is that if, what does this expression actually relate to? Is it that I need to actually align it on 2-byte boundary and I'm just stupid? That might be it. It looks to be the case. Yep. Actually, count of codes plus 1. No, it's just, it basically does -1 in a very, or no. No, it does alignment. So I'm just stupid. Okay, I should have paid more attention. So exception, let's say that it's this U64 exception handler index is U64 align of this to 2, and then we do it like that. Okay, well, let's verify that we rebuilt, and one more try. Assembly, call. Well, we didn't crash. That is one thing. Yeah, okay. Great. So actually, I should have read better that weird thing and should have paid attention. But honestly, also in documentation, they could have just said you have to align the thing instead of giving this weird expression, which is only even given in one place. Like here, it should have said exception handler should be aligned to the right size. Okay, cool. Well, that was a very, very long investigation, but you know, sometimes it happens. Sometimes you go into wild goose chases, and sometimes you have to figure stuff out. But that's the real programming experience. So here we go. Now we have this thing being executed. So we have the right. We have an exception handler here, and that means that in here we could start doing cool things. One last thing I will actually do here is to show you. I think it's going to be an LU, so I can do context record rip, I think. And let's put this like this. So the cool thing now is that we have the instruction pointer. Actually, LX would be nicer. But regardless, we have an instruction pointer, and that means we should be able to use the data that we put there ourselves, which are these runtime functions, to start unwinding the stack, and not for the purpose of any actual error handling, but just for the purpose of understanding which functions we are hitting. And since at least in JIT mode, we know exactly which functions we were hitting, where we could store that runtime function data in the function builders, we should be able to eventually print the stack trace. But that's definitely it for now. That would be for the next time. It was tough, but it's finally working. So if you were screaming at your screen the whole time that I should have done that alignment, then nice catch. Otherwise, thank you very much for watching, and hopefully see you next time.